telescope caught a smell that on Earth only life makes. It was drifting in the thin air of a planet called K2-18b, a world 120 light-years away in the constellation Leo. Say the name once because you are going to hear it a lot. K2-18b. For 1 week in 2025, it was the most famous planet in the sky. On the 17th of April, a team in Cambridge stood in front of the world and said James Webb had caught the fingerprint of life in that planet's atmosphere. And the headlines wrote themselves. Strongest sign of alien life ever found. Some outlets dropped the caution completely. We found it. We are not alone. So here is what I'm going to give you about K2-18b. By the end, you will know exactly what Webb saw. In plain language, you will know why the scientists who found it refused to call it proof. And you will know the one fact that quietly takes the whole headline apart, because there is a detail buried in this story that almost all of the coverage skipped. A piece of chemistry that did not fit the dream, so it got left out. That same gas of life has turned up in a place where there has never been a single living thing. We will get to it. First, you need to meet the planet everyone got so excited about, and notice how badly you want it to be true. That want, yours, mine, the scientists', is what this whole story is about. Here is the belief the headline leaned on. On Earth, this gas is made almost only by life. Catch it in the sky, and something living must have breathed it out. On Earth, it rises off the ocean, breathed out by tiny plankton by the millions of tons. Life makes it, and almost nothing else does. So the logic felt like a straight line. Find it in the air of another world, and something there must be alive. That is the promise the whole headline rested on. And it is the promise this planet is about to test. K2-18b is an awkward size, and that awkwardness matters. It is about 8.5 times the mass of Earth, and a little over twice as wide. In our own solar system, nothing sits in that gap. Earth, then a jump, then the ice giants. K2-18b lands right in the missing middle. Bigger than a rock like ours. Smaller than a gas world like Neptune. And astronomers still argue about what worlds in that gap are made of, which it turns out is the crack the whole life story slips through. It circles a red dwarf, a star smaller, cooler, and far dimmer than our sun. It sits in close, finishing a full year in about 33 days. On paper, that close orbit should cook it. But the star is so faint that the planet lands in the habitable zone, the thin band of distance where a world could, in principle, hold liquid water on its surface. In principle. Keep those two words nearby. They do a lot of quiet work in this field. We found it back in 2015, when NASA's Kepler spacecraft watched the star flicker. A tiny repeating dip as the planet crossed in front of it. For years, that was the entire biography of K2-18b. A dip in a light curve, a line in a catalog of thousands. No headlines, no fame, no reason to think it was special. It took a bigger eye and a stranger method to turn that dot into the most argued-over planet of the decade. Then James Webb turned toward it. And here is the first thing that surprises people. This telescope does not photograph a planet like K2-18b. It cannot. From 120 light-years away, the planet is a mote of dust lost in the blazing glare of its star. What Webb does instead is quieter, and far more clever than any photograph could be. It does not look at the planet. It tastes its shadow. When the planet passes in front of its star, a razor-thin sliver of starlight filters through its atmosphere on the way to us. Every gas in that air drinks up its own specific colors of light and lets the rest pass. So the beam that finally reaches Webb, after 120 years of travel, arrives with tiny, precise gaps punched into it. Each gap is a barcode for one molecule. Read the pattern of what is missing, and you can read the air of a world you will never visit. Its methane, its water, its faint exotic traces. You are, in a real sense, smelling a planet by the shadow it throws across a star. From a distance no human craft could cross in 1,000 lifetimes. In 2023, Webb read that shadow for the first time and found two gases, methane and carbon dioxide. That sounds unremarkable until you hear the rest. It was the first time we had ever detected carbon-carrying molecules in the air of a planet, inside another star's habitable zone. A genuine first. And it snapped neatly into a beautiful idea that one astronomer had been building for years. The idea is called a high Ceon world. Picture a planet drowned under one endless global ocean, wrapped in a thick hydrogen sky. No continents, no coastline, only water from pole to pole under a pale hydrogen haze. Nick Madhusudhan, the Cambridge astronomer leading the work, argued that these ocean worlds might be the single easiest place in the galaxy to go looking for life, because their puffy atmospheres are so much easier to read. His phrase for it was that high Ceon worlds are more conducive to atmospheric observation, and tucked inside that 2023 data was something more than methane. A whisper. A faint hint of a third gas right at the edge of the noise. Too weak to trust, far too tempting to ignore. Because that third gas was not another boring carbon molecule. It was the one that chemists on Earth tie, almost exclusively to living things. That whisper is what sent Webb back to the same dim star for a second. Longer, harder look. And that second look is where the world lost its mind. The gas has a name, dimethyl sulfide. On Earth it pours off the surface of the ocean, breathed out by marine plankton by the millions of tons rising into the sky and helping seed the clouds. As far as we knew, life makes it, and almost nothing else does. So the logic was a straight line, and a thrilling one. Find dimethyl sulfide in the air of another world, and something on that world might be alive and exhaling it. In April 2025, the Cambridge team announced they had found it. Dimethyl sulfide, and possibly its chemical cousin, dimethyl disulfide, in the atmosphere of K2-18b, and not a faint trace this time. They estimated concentrations above 10 parts per million, thousands of times richer than anything in Earth's own air. Madhusudhan described the moment without much hedging. The signal, he said, came through strong and clear. He called it the strongest evidence yet for life beyond the solar system. But listen to his actual framing, because the world ran off with a louder version than he gave. What he said was that a high Ceon world with an ocean teeming with life is the scenario that best fits the data we have. Best fits, not proven, not confirmed. The scenario that best fits. Those are different sentences, and the entire rest of this video lives in the gap between them. And to his credit, he immediately warned that the molecules might be produced by some chemistry we do not understand yet, with no life involved at all. That caution barely survived the trip to the front page. But he said it. The man who found the signal told everyone on day one to be careful with it. The question is, what happened when other scientists took him at his word and started pulling the result apart? Here is the one number that will carry you through the rest of this. The Cambridge result reached what scientists call 3 sigma. In plain terms, that means roughly a 0.3% chance the signal is a random fluke, about 1 in 300. And when you say it like that, it sounds like a near certainty. It is not. In this game, it is nowhere close, because to announce a real discovery, physics demands 5 sigma. That is less than 1 chance in a million that you fooled yourself. 3 sigma is a strong hint. 5 sigma is a finding you would stake your name on, and the distance between them is not one more careful step. It is a canyon. It is the difference between, I think I see something and I am willing to bet the field on it. K2-18b was sitting down at 3. A hint dressed up for a week as an answer. And Makda Sudan knew it. It is important, he told reporters, that we stay skeptical of our own results. He did not ask the world to celebrate. He asked for more telescope time, 16 to 24 more hours of Webb staring at that single faint star, enough to push the signal up toward 5 sigma, or watch it crumble. Think about what that means. The entire question of whether we share the universe with anything alive came down to less than 1 full day of one machine's attention. Not a fleet of ships, not a landing. A day of patient looking and a willingness to accept whatever the light came back and said. Now the detail I promised you at the very start, the one that quietly takes the whole headline apart. Remember the foundation the excitement was built on. Dimethyl. Sulfide means life because on Earth, only life makes it. That single sentence is the load-bearing wall of the entire story. And in the very same years Webb was sniffing at K2-18b, other scientists walked up and knocked a hole clean through that wall. They found dimethyl sulfide in a comet, in the frozen material of Comet 67p, the icy wanderer that Europe's Rosetta mission chased across the solar system and studied up close. A comet has no ocean, no plankton, no life of any kind, not now, not ever. It is a dirty snowball older than the Earth itself. And the so-called gas of life was sitting right there in it, cooked up by nothing but cold chemistry and deep time. Then it got worse for the clean story. Astronomers reported the same molecule drifting in an interstellar cloud, raw gas floating in the dark between the stars, where biology is not even a question you would think to ask. So the wall does not hold. Dimethyl sulfide can form with no living thing within light years of it, which means catching it on K2-18b is a clue, and an interesting one. But it was never on its own. A signature. The dead universe knows the trick too. Cold reactions on ice grains, ultraviolet light breaking apart bigger molecules. There are quiet, lifeless ways to build that same smell, and we are only starting to map them. Sit with that for a moment. Because it is the hinge of the whole thing. The entire reason the headline could say, life, was that this gas was supposed to be unfakeable, a word only the living could spell. And nature had already been faking it quietly, in comets and cold gas clouds, long before we ever pointed a telescope at K2-18b. The smell of life, it turns out, is a smell the lifeless cosmos can make on its own. And that warm global sea, the one where the plankton was supposed to be breathing, we are not even sure it exists. While the Cambridge team painted their ocean world, another group of scientists ran the same planet through their models and came back with a colder, flatter answer. K2-18b, they argued, might have no surface at all. No ocean to stand beside, no shore, nothing to be alive on. Their model is a gas-rich mini-Neptune. Picture a thick hydrogen atmosphere going down and down, getting hotter and denser the deeper you fall, until there is no clean line between sky and sea, because there is no sea. And the methane and carbon dioxide Webb found? In this picture, those form on their own, deep in that crushing air, through ordinary high-pressure chemistry. No life required. The same two gases, from a completely dead world. They also pointed at cracks in the ocean story that are hard to fill. A thin hydrogen sky sitting over a warm ocean tends to run away into a scalding steam furnace, not settle into a calm blue sea. And that light hydrogen should slowly be stripped off into space by the young star's radiation, especially early in the planet's life. Their case rests on the plainest rule in all of science. The answer that needs the fewest new assumptions usually wins. And a dead mini-Neptune asks for far fewer miracles than an ocean brimming with alien life. Then came the part that almost never makes the front page, but quietly decides what is true. Other teams took the exact same Webb data, not new observations, the very same numbers, and ran the analysis again themselves. People who had no stake in the original claim, checking the work line by line. This is how science is supposed to work. It is also not gentle, and it was not gentle here. A team including Raphael Luque, Kaira Linpyo Le Guriyeub, and Michael Zhang combined all three of Webb's instruments together instead of leaning on the one that showed the strongest bump. And when they did, the strong, clear signal went soft. Piaule Gurayeub put it flatly. They never saw more than insignificant hints of either gas. Luque called the detection not statistically significant and not robust. They even showed the same wiggles in the light could be reproduced with no dimethyl sulfide in the mix at all, and a separate analysis reached the same wall from a different direction. In a paper whose title says the quiet part out loud, the conclusion was that K2-18b does not meet the standard of evidence for life. Not that the planet is dead. Not that Meshda Sudan was reckless. Only that the data we have, examined honestly, does not clear the bar. 3 sigma recombined and rechecked, slid back down toward noise. The strongest sign of alien life we had ever found was coming quietly undone, in public. Exactly the way it should. So, did James Webb find a sign of life on K2-18b? No, it did not. What it found was the precise edge of our own ability to tell. And that is a stranger result than the headline, and a more important one, because it turns the whole story around until it is pointing back at us. Here is where a channel could cheat you. It could hold that alien question open forever, dangle it every few minutes, and never once tell you where the science stands, because the not knowing is what keeps you in your seat. I am not going to do that. The honest status of K2-18b today is a real open question and nothing more than that. An intriguing planet, a contested fading signal, a clue worth chasing, not a discovery. Anyone who tells you otherwise is selling you the ending you wanted. And yet, this is the part that gives me chills. We can settle it. That is the quiet marvel underneath all the noise. 120 light-years away, a question about life on another world now comes down to a few more hours of one telescope's time. Point Webb back at that dim red star, gather more light, and the signal either climbs toward 5 sigma and rewrites everything, or it sinks into nothing and we move on. For the first time in the history of our species, the question, "Are we alone?" is one we are equipped to test, which is why K2-18b turned out to be less a planet and more a mirror. It handed us everything we had wished for across 100 years of looking. A world in the habitable zone, a gas that smells like life, a headline that could write itself. And then it asked us one hard question in return, and stood there waiting. Can you tell the difference between a discovery and a hope? Because we still do not know if that world even has an ocean, or only a bottomless sky with no floor. We do not know if dimethyl sulfide should ever count as proof of anything, now that we have caught the dead universe making it in comets and empty space. We do not know what, if anything, is alive out there. The math does not break here. Our certainty does. And learning to feel the difference, that might be the most grown-up thing our species has ever done. So maybe that is the real find. Not life. Not yet. But the moment we stood at the edge of the oldest question we have, with the answer we always wanted right there in our hands, and chose to say, "Not proven, not yet. Check it again." The day we finally find life, it will not shout. It will whisper, exactly the way K2-18b did, and we will spend years being brave enough to believe it. Every world we will ever question is going to be that faint. A shadow on the light of a distant star, and a smell we have to be honest enough to doubt. The planet that finally proves we are not alone will not arrive with a banner. It will show up as a wobble in a graph, a hint at 3 Sigma, a name we can barely pronounce. A telescope caught a smell that, on Earth, only life makes. It turned out to be a question, not an answer. But the next faint signal is already out there, sitting in data nobody has looked at closely enough yet, on some dim world circling some distant star. And when it comes, the only thing that will matter is whether we are honest enough to know what we are seeing. K2-18b was practice. The real thing is still coming. That's as far as this one goes, but the edge always moves. This is Aphelo. Subscribe, drop a like if it earned it, and your next one's on screen now. I'll meet you a little further out.